In this video, we are going to understand about local privilege escalation on Windows. Before that, we are going to understand some of the terminologies and the security architecture of Windows. So the first entity that comes into picture is security principal. The users and groups which are created in the system are known as security principals. And the process and the threads created by the security principals are known as subject. And these subjects act on behalf of the security principal. Now, there is another entity known as securable object. Processes, files, services, registries, network shares are different types of securable objects. Now, what happens when the principal or the subject tries to access a securable object? So the subjects and the security principal have a security token. So when a user logs into a system, he is assigned a security token. A security token has a field known as SID or security identifier, which uniquely represents the user who created this particular process. Now, securable object has a data structure known as security descriptor, which determines who can access this securable object and what kind of access he will get. Now there is another data structure inside the security descriptor known as ACL or the access control list. And access control list have another structure inside them, which is known as ACE or access control entries. So the access control entries tells who can access this particular object. For an example, here the user with SID_1 is allowed to access this particular object and he has got read access. Now, when the security principal tries to access this object, so the SID, which represents the user who created this particular process, is compared against the SID, which is inside the access control entry inside the security descriptor. And this kind of ACL is known as DACL or discretionary access control list. Now there is another parameter which can be used to determine whether this particular object can be accessed by the security principal or the subject or not. So that is known as integrity SID, which represents integrity level. So the access token has a integrity SID and the security descriptor also has another field known as mandatory label access control entry, which has integrity SID. So integrity level of this particular object determines what kind of data it has and what is the sensitivity of the data. So you can say a process with a lower whose token has lower integrity level cannot access an object who has a higher integrity level or which is supposed to contain a data with high sensitivity. So the comparison happens between the integrity level, which is inside the token, and the one inside the security descriptor. And the security principal or the subject is allowed to access this object only if the integrity of the process is equal to or higher than that of the security descriptor. And always this comparison holds more priority than the comparison of the DACL. Now coming to Windows privilege escalation attacks. So here is a malicious process and here is an admin user. Here is an admin process which is created by an admin user. And in typical token stealing attacks, the token which is owned by the admin process is stolen by the malware process. So this is the simplest way I can explain a token stealing attack. So there are many underlying APIs involved while looking into this kind of attack. Next is the UAC bypass attacks, which is another kind of privilege escalation attack. So different processes in Windows operating system have different integrity level. So the integrity level starts from untrusted to low to medium to high to system, in which system has the highest integrity level and untrusted has the lowest ones. So you can say a process with high system integrity with a high system integrity level can access object with more sensitivity, or you can say it can access files which are system files. For an example, the files which are present in system 32. But a process with low integrity cannot access the system files. Now, what the malware does is it will try to increase its integrity level. So by default, when you execute a process from a normal user, it is supposed to execute at medium integrity. And the malware will try to increase its integrity level to a higher integrity level. Now, any process which tries to get run as an administrator user with a high integrity level pops up a UAC prompt. But in case of UAC bypass attack, this prompt is bypassed and it is never popped up. So this kind of attacks are known as UAC bypass attacks. If you want to know more about reverse engineering techniques like UAC bypass and more stuff on malware analysis, reverse engineering, detection engineering, you can learn at academy@intelliroot.com. Thank you.